We're starting section 1.5 today. We were going to do this together in class on Labor Day, but we're going to do this by video so you can kind of have the day off and do it whenever you have time. So you'll find this handout linked on our Blackboard page, the 5 basic functions handout. All right, and these are just 5 functions that we're going to use a lot to talk about the rules of transformations. So we have the graph of x squared here, and all I've done is gone through and plot a few points. So I took -2 and then plugged it into x squared. So -2 squared is 4, so I plotted the point -2, 4, and you see that up on the graph. So I did that with 5 points, and we get this shape that certainly is familiar to you from high school, that parabola shape. And in general, I just want, when I say x squared, that you think in your head that parabola shape, that U-shaped graph, and that you would know that the bottom of it sits at the origin. All right, so our second basic function is the absolute value of x graph, and plotted a bunch of points for that one. And this one ends up being a straight line V-shaped graph that sits also at the origin with a 90-degree angle there at the origin. And the absolute value of x graph is the only one that we're going to talk about that has a sharp curve. Pretty much everything else we do in pre-calculus is a nice wavy or curvy graph. Our third one is the square root of x. Notice I only plot positive x values for this because we can't take the square root of a negative number in this class. And if you turn your head to the left, it kind of looks like half a parabola, which it is. It's very much related to the graph of x squared. And keep in mind for this one, to the right, it keeps going, so you could put an arrow there. And on the left, 0 here, it comes to a dead stop. All right, next up. X cubed. All right, so x cubed on the right kind of looks like that parabola shape, maybe like a stretched out version of it, taller version. And on the left kind of looks like an upside down parabola. All right, so when you cube negative numbers, you get negative answers, which is why the negative x coordinates end up with negative values, the positive ones with positive values. All right, and our last graph is the cube root of x, and that looks a whole lot like x cubed with good reason. Those are partner functions. And this one kind of looks like the square root graph, but it also has that left-hand side because you can take the cube root of a negative number. So we'll be using these functions a lot today as we talk about transformation rules. So this is the second handout that you'll see posted on Blackboard, this transformation rules handout, and we're going to fill this out today, just kind of looking at what happens to a graph when you alter the formula of it just a little bit. All right, you will also find this Desmos link on our Blackboard page. We're just going to kind of use this to investigate what happens when we start messing around with the formula of a function. So I've got one of our 5 basic graphs here, x squared, and we're just going to see what happens when you add or subtract a number outside the function. All right, so I'm just going to pick, I'm going to do x squared, and then I'm going to just add any number. So let's pick 3. Okay, so x squared plus 3. And you see that you get the same basic shape, the same x squared shape, but it's been shifted up, and specifically up 3 units. So it's like it just copied that same shape up 3 units. All right, so what about if we subtracted a number, x squared minus 1? Now let's do a little bit more than that, x squared minus 5. All right, and probably predictably, this moved the function down, and it moved it down 5 units. So essentially all we're doing is taking y coordinates and either adding or subtracting and figuring out where it goes. So let's try this out. We kind of have this idea that if we add, then it moves the graph up, and if we subtract, then it moves the graph down. So let's go to the try it out. All right, so here I have that x cubed graph, and this is one of the ones that's on the 5 basic functions handout. And let's see, we're gonna try adding or subtracting to x cubed. So I'm gonna say x cubed and then add 2. And it does the same thing, just with this shape. So it takes this shape and moves it up 2 units, and I could subtract 2 instead if I wanted to. And sure enough, it takes that dotted x cubed basic shape and scoots it down 2 units. All right, and likewise, it does not matter what your starting shape is. You can take the square root of x, and then you can add or subtract any number that you want. Okay, so when I take square root of x and I add 4, it just goes up 4 tick marks and copies that exact same shape. All right, so that is adding and subtracting outside the function. So let's go back to the transformation handout and take some notes on that. All right, so we're going to say that the graph of f of x plus c, so I'm going to let this c number represent what we're adding. Okay, so if we know the graph of f of x, the graph of f of x plus c is just the graph of f of x, that same basic shape, shifted up c units. Okay, whatever number you add, that's how many it goes up. And then we'll say the graph of f of x minus c is the graph of f of x shifted down c units. All right, so that's what happens when we add or subtract outside of the function, outside of the square, outside of the absolute value bars, things like that. So let's go investigate what happens when you add or subtract inside the function. All right, so here I have the absolute value of x graph. Remember, that's our V-shaped 90-degree angle graph there sitting down at the origin. And we're going to talk about adding or subtracting inside the function. So instead of taking absolute value of x, and then coming outside, we know what that's going to do, right? If I do plus 3, I know that's going to scoot it up 3. But what if I take that addition and I move it inside the absolute value bars with the x? Okay, so plus 3, and then close those absolute value bars. Okay, now that moves it horizontally, and this one's a little bit surprising. So when I added outside the function, it went up, and I subtracted, it went down. That's kind of what we expected. On the inside, when I add 3, all of a sudden it moves over to the left. Okay, so let's see if that happens. See if it's backwards when I do absolute value of x. Let's subtract. I'll do minus 4. And sure enough, very oddly, it's kind of going backwards of what you would expect, right? X plus 3 moves it to the left. F minus 4 moved it 4 units, but it moved it to the right. Okay, so this horizontal rule, adding or subtracting inside, goes backwards. So the best way that I can give you an intuition about this, so if I look at that x minus 4 graph, the green one, if I want to get the v part of that graph, remember that's normally over there at 0, 0. So I need to find that y coordinate of 0. The way I get that y coordinate of 0 is by plugging in a positive 4. 4 minus 4 would give me that 0 point. Likewise over here with the plus 3 graph, okay? If I wanted to find that 0 point, for plus 3, I'd have to plug in a negative 3 in order negative 3 plus 3 would give me 0, and that's where that v point is going to be on the graph. All right, so let's just try out our rule and make sure it works for the other ones. All right, so x squared, we know what it's like to add or subtract outside. Inside x squared means that I'm going to put a set of parentheses, and we'll try x minus 2 squared. All right, and sure enough, it takes that x squared graph and it moves it to the right. And again, kind of backwards of what we might think. And then the cube root of x, I've got that. Let's do the cube root of x. Got to go over to the functions, miscellaneous. That's where my cube root of x graph is. Cube root of x. And then when I'm going to be inside the function, let's add, because we did subtraction with the other one. Let's add 6. That means inside means under that radical, inside the house. Okay, and sure enough, it is moving it to the left when we add. So let's go write this rule down. All right, so we've been adding and subtracting inside the function. So now I'm going to say f of x plus c inside the function parentheses. And that means inside the square or inside the house of the radical. And again, adding went opposite of what we think. If we add, then we're going to end up going to the left. Okay, so this is going to be the graph of f of x shifted left. All right, and then when we did f of x minus c, we're subtracting inside, it's going to go to the right c units. All right, so we've got 3 blanks left to fill in, and that's what I'm going to do in the next video.